The reason that we often tend to point people towards comfort and health is because if they're already in a building, oftentimes the reason they want to retrofit it isn't just to save energy. They also want to save energy. But we find from our clients, the things that really drive them to do a retrofit that makes sense to us is when they're looking to get those comfort and health benefits for themselves.
ProClimber inspires and educates people to create healthy, durable and energy-efficient buildings to live, learn, work and play in. Welcome to the ProClimber podcast. In this week's episode, we're joined by Jason Quinn, who's a true rocket scientist. Jason and I discuss his soon-to-be-released book, focusing on high-performance home retrofits. All right, Jason, welcome back. Great to have you on the podcast again. How are things going on your side?
Going quite well, Simon. Thank you.
Now, Jason, if you can just give the audience a little bit of an introduction to yourself, perhaps for people that didn't hear our last podcast.
Yeah, so my name is Jason Quinn. I'm the founding director of Sustainable Engineering Limited, which is a small building science consultancy. We've got about 6 staff, and we do pass-house design and certification, a lot of hydrothermal modeling and energy modeling. We do a lot of dynamic and more advanced modeling like zonal dynamic models and such for clients. So building science is kind of our specialty, is what we do as a business. And that's what I do personally. And let me think, probably semi-famous that I used to work at NASA and actually worked at Rocket Lab for a little while too, now that I think about it. But those things are all firmly in my past. So it's been buildings for quite a while now.
You're in the process of writing a book that I heard about recently, and that's why I've approached you to join us again. And in the introduction to that book, you say, I'm often asked for a simple plug-and-play solution for retrofits. The short answer is there isn't one. So, Jason, just give us a little bit of an idea. Who are you aiming this book at?
Yeah, so if you're talking about the deep energy retrofits for New Zealand book that I'm working on, the book's aimed at designers and architects and builders and perhaps more technical homeowners. So it's designed to take a builder or an architect and kind of walk them through the process you'd go through to deep energy retrofit, both for the building envelope, like the roof, walls, and floors, as well as the systems that are in there. And there isn't any organized single publication that a builder or a designer or even a technically oriented homeowner can use to kind of go through that process. And it is a process. There's easy solutions once you have a specific problem. But if you want to talk about retrofits as a general, the solutions tend to be very specific to the building.
Jason, we've got a huge problem, haven't we, in New Zealand? We've got, New Zealand Green Building Council talks about some 800 houses that were built before insulation was even required. We've got single glazing, lots of problems with damp and moldness. So when we were talking just before the interview, you mentioned that a good starting point when you sit down with someone is to do something you're calling a performance snapshot. Can you tell me about that?
I think Green Building Council said there's about 800,000, almost 1 million houses built before there was insulation requirements. And certainly even ones that were built after the insulation requirements a lot of them are still quite cold and damp, unfortunately, for various reasons. And for various reasons is why we tend to want to do a performance snapshot when we do our buildings. What a performance snapshot means in our business is we run a full site-specific energy model of the building, a simplified one, and that lets us see what knobs to turn to make the building perform. So oftentimes we've had clients that have gone off without our help, unfortunately, and had quite a bit of retrofit work done at home, and they haven't gotten any felt benefit to the building because the things they improved are already pretty good already, and the things they didn't improve, they didn't realize are really quite impactful. So oftentimes air tightness, for example, can be something that's not considered. And that means that, people will do just simple draft proofing and they won't realize that they've got bypass going on inside their assemblies, which means there's air blowing through the insulation. So the insulation is not actually working when there's a winter storm, let's say. And so by doing a performance snapshot, you do get that overall picture of the building, which lets you know, well, if I put in this sort of glass or these sort of frames, what's the benefit numerically? So you actually know the benefit. It's not just a guess. It's not just a sales pitch from a particular supplier. Not that I'm saying anything bad about you, of course.
Another point that you mentioned in the beginning of the book is around a fabric or a system approach to retrofits. Tell us about that.
I wish I could think of a good religious analogy where it's like, oh, I know. It's like the Christians, like some churches in Europe, you don't wear a hat. Like you have to take your hat off to go in because it's disrespectful to wear a hat. And then across some imaginary line in Europe, and I'm sure it's Eastern Western churches or something, you have to wear a hat. Like to not wear a hat is actually insulting and you have to wear a hat, right? So there's this hat versus non-hat. So this fabric versus system approach is a similar kind of dichotomy where you'll have folks argue that, we should do heat pumps first and then do building upgrades, and other people say, well, you've got to do the building upgrade first so you don't oversize the heat pump. They make it seem like this dichotomy, like you have to wear a hat or don't wear a hat, whereas in reality, both these things can be improved, and it's a matter of what makes sense for a particular project. For what I consider deep energy retrofit is something where you've fixed pretty much the whole building as much as it makes sense to fix it, right? That doesn't mean you do it all at once. You might do it over 50 years even, right? Because if you got a nice brand new roof, I wouldn't fix the roof until the roof needed to get fixed. So when you look at systems or the building, you need to look at them both at the same time and decide what's going to go first and how it's going to play. When you're looking about heat pumps don't have a very long life expectancy. They only last, say, 15 years typically. If you're on the coast, it might even be less than that. If you're inland, you might get almost 20 years, but that's really unusual. And if you're going to insulate the building, you'll need a smaller heat pump. So do you put in two small ones? So when you insulate the building, you can get rid of one or sell one. Or you're going to do insulation 10 years from now, in which case the heat pump will actually have used up most of its lifespan anyways. So the important thing is to take a look at the building as a whole and what you're going to improve eventually and make a master plan, as it were. It doesn't have to be super detailed. In fact, it shouldn't be because it's going to change with time. But if you just go ahead and just jump in and put in a new heat pump that's going to be adequate at day one, and then next year you're going to replace all the windows for double glazing, your heat pump's now perhaps quite oversized, which means it's short cycles and doesn't perform well, and it can impact the lifespan of the heat pump as well.
In your book, you also talk about a sort of the numbers that people are expecting. And one of the case studies you look at was improving a certain building from 370 kilowatt hours per annum per square meter down to 58. And in the process of that, you've got a number of the different areas, and you sort of discuss the benefits of, for example, the windows, the walls, the floor, the ceiling. Do you want to have a sort of a breakdown and give us an idea where you can get your quickest wins in the beginning?
This is going to be a bit counterintuitive, but the quickest win in a retrofit is to fix things when they're broken. So if you have to replace the windows, then replacing the windows with the windows that are going to be the ones that you're going to want in the end makes good sense, and that's the quickest win. If you've got a building where everything's quite tidy and it's all in good nick, then I'd argue the quickest win would be putting mechanical ventilation in, to be quite honest. And that's not going to be an energy win. I know you started with reducing from 300 down to 60, but oftentimes the health impacts of putting in fresh air all the time at the correct flow rates, so you don't have high CO2 while you're sleeping and don't have particulate pollution the rest of the time, are tremendous. They're much more impactful than any energy savings even. But when we look at buildings, it depends a lot. If you've got a truss roof building with poor insulation in the ceiling, you often can moderately airtight the ceiling, like go up and do some things in the ceiling to airtight it a bit more, and then add insulation safely in that truss roof ceiling. And that is going to be the lowest cost upgrade, as it were. In general, I don't recommend draft proofing as a first step. I know it's the first step you'll see in every little. I used to read Tree Hugger a long time ago. I don't know if it's still a thing, but Tree Hugger was like one of these sites you used to always read back in the day, right? And it was always the first thing on the list was draft proofing, right? Because you could fill a sock with rice and put it on the door and you're done, right? You did something. And it makes you feel good because you did something, right? But that infiltration in a regular house without proper ventilation in it was perhaps serving quite a bit of service to you. So oftentimes things like just doing draft proofing or just doing X or Y to a building can actually make the building perform worse in a lot of ways that matter to people, including, of course, if you draft proof without adequate ventilation, you can cause moisture problems, right? Those aren't moisture problems inside the walls of the building generally. They're generally mold on the surface in the room you're living in, but that's a real problem.
When you're discussing one of these sort of projects with a customer, obviously a lot of people think, oh, well, it's all about the sort of return on investment, how much am I going to save on my power? But you mentioned that maybe there's another way that people should be looking at it, which is more around the comfort and the health value alongside of that. Can you dig into that a little bit deeper?
So if we talk about just comfort and health, the benefit you can get in a deep energy retrofit is, first of all, you can get comfort like you would have in a new passive house, right? Where you can use the entire space, even right up to the windows, because you've got thermal comfort right up to those windows. And then in the health space, because you've got control of fresh air, like you have fresh air supply to the building, usually through some sort of mechanical ventilation, either continuous extract or balanced mechanical heat ventilation with heat recovery. And then you've got air tightness in the building to some level because you can retrofit both those things. You then have a tremendous health impact. So the numbers that are coming out of these meta studies in Europe for controlling PM 2.5, so these small 2.5 micron particles that can, when you inhale them, they can actually go directly into your bloodstream. The health impacts from doing that are often on the order of like several $100s per person per year of benefit. That pays for the ventilation system and the air tightness required quite quickly in a period of very few years. The reason that we often tend to point people towards comfort and health is because if they're already in a building, oftentimes the reason they want to retrofit it isn't just to save energy. They also want to save energy. But we find from our clients, the things that really drive them to do a retrofit that makes sense to us is when they're looking to get those comfort and health benefits for themselves. I think that's probably the best way to put it.
So obviously there's a reasonable amount of work and financial expenditure based on doing a retrofit. How do you actually work out whether it's better to scrap it and start from scratch or to do a deep energy retrofit?
Yeah, so there's a complicated and a simple answer to that question. So let's just go with the simple one, which is the best thing to do is if you're looking to do a deep energy retrofit and you're deciding, well, do we actually renovate or do we go ahead and bowl it and start over or something in the middle? I think the most important thing is to think about what you're saving and what the value is. So like my favorite retrofit would be a nice old villa, which my girlfriend's house was a good example of this, where the inside was really quite good and lovely, right? But the outside was quite tired. Her windows, I remember one morning a window fell out of the wall. The cylinder rotted out and it just fell out of the building. So, I ran outside with a screw gun and screwed it back in. Anyways, so that means because the inside's in quite good condition and has been maintained well, but the outside is past it, when things failed, such as the windows in this case, because it literally fell out of the building, the windows needed to be replaced because there were several that were rotten. They all needed quite a bit of maintenance that had been avoided in the last 100 years because the building is about 100 years old. So that made sense to put in a deep energy retrofit sort of windows in there. And that made economic sense. In the end, they actually cost less than the standard aluminum windows we would have gotten down the street because the builder was interested in doing things properly and they were put in insert style. We left the existing timber frames in the walls and flashings and inserted those in, which meant if we'd put in standard aluminum windows, like modern ones that weren't quite at the level we wanted for this deep energy retrofit, then we would have had to tear out all those frames. It would have cost even more than what we spent in the end. If we're looking at cost effectiveness in a retrofit, what tends to make the most sense is to do a step-by-step retrofit we've talked about, which we'll talk about in a bit. But the idea that basically as things fail, you replace them, but you replace them with the final goal in mind, which is having a very high-performance building that is supremely comfortable, very healthy for your family, and as well as saving energy, right? There's meta studies out of Europe talk about drastic improvements to what they call disability-adjusted life years. Like I said, it's several $100s per person in a house. So you might be saving something like a few $1,000s a year in health costs by having a proper ventilation system in a home. So,
sort of digging into a bit of the details now that we've discussed the overall idea of a retrofit. Well, there is the standard known as EECA, which is obviously the passive house retrofit standard. Tell us a bit about that. And if people are not aiming at that, what sort of number should they be aiming at?
That is sometimes the $1 million question, right? Not $1 million, but maybe $20,000 question. So the nice thing about EECA, it's the energy retrofit standard for the passive house approach, is that there's two different approaches. There's two strands in the EECA, right? There's the energy demand method, where you're trying to hit a total modeled energy consumption for the building with defaults, right? We try to get under, let's say, 20 or kilowatt hours per square meter per year for a building, right? And then there's the other approach, which is called the component method. And the component method effectively has a list of, if you want to call it, R values for the building for different climates. And what you find is that, at least in Auckland, for example, since we're talking on a New Zealand podcast, R values are very similar to what you have for a new building in our building code, right? The difference being in that the way we calculate R values for building code are leave out a lot of energy losses, as it were. So whereas when you do it with the retrofit approach, it's actually the effective R value that you would expect to see in practice. So the reason I like retrofit and the difficulty I have in defining deep energy retrofits any other way is that retrofit says you have this set of targets, either an overall energy or your walls should be this good, windows should be this good, floors should be this good, roof should be this good, right? Which gives you a defined target to look at. Otherwise, you might say, oh, I don't want to do retrofit because I think it's not cost optimum for here. I think New Zealand building costs are higher than Europe, which they are. And windows cost more than they do in Europe, which is true, unfortunately, because of volume. So therefore, I think something less than retrofit is the right answer. And I'm like, okay, well, to do that, you would do an energy model with different inputs, and you would basically you'd quantity survey them, the different improvements, and you'd say, okay, where's the best payoff per benefit? And the cost to do that process is actually quite expensive because it's quite time consuming. So your choices really are to use retrofit, or what's been done overseas. In some cases, they'll use retrofit, but they'll take out some pieces. Like they might say, instead of requiring an air tightness of 1, air change at 50 pascals, which is what's required by retrofit, it has to be tighter than that. Might say, okay, well, you can be up to 3. And in Auckland, maybe that is a reasonable approach. Maybe that is more cost effective. I don't think that there's actually much cost in going from an ACH of 3 to 1, but that's another story. So generally, we aim at retrofit, and if folks have particular portions of it, like air tightness or glazing, that they don't want to attack because they think it's not cost effective, we'll tend to just roll back those pieces and still use retrofit as an overall kind of approach to define the target. And the main reason being is that it's really, really hard to figure out another target that makes sense. And then I don't want to get too much into the details, but in the UK, the Passfels Trust in the UK has just done a big study across looking at deep energy retrofits in the United Kingdom, done to the retrofit standard, done to like an retrofit light standard, and then done to a couple other near zero energy standards similar to retrofit. And that were supposedly easier. They have lower air tightness targets, lower R value requirements, so the lower performance, right? And the costs were effectively the same. The reality is that construction's expensive. The additional cost when you're doing retrofits to get the performance up to something like retrofit is oftentimes not very much at all. If you think about putting new windows in a small home, maybe you're spending 40 or 50K for the windows. If you wanted to put in ones that were suitable for retrofit, maybe they would need to be triple glazed instead of double. In most of North Island, that's not true, but in the South Island, it would be. And you might find it's going to cost you an extra 20%, right? Something like that. And the labor's the same. The tenting, the building's still the same. What the cost is really just the cost is the glass.
Are you better facing this challenge from going from the inside or from the outside for the retrofit?
So we kind of got off topic a little about whether or not to do deep energy retrofits or not to demo them. So let's kind of jump back into that again. So when you're looking at deep energy retrofit or an retrofit project, either one, the most important thing is to think about what you're going to save. So if you have that nice old villa, I started talking about how the outside was crap. We're going to take off the outside. So that made sense for that building because when the windows failed to replace the windows, when the cladding eventually comes off, which it's starting to, and the roof is finally rusted through, which it's starting to, then we can do the outside at that time, right? Because it needed to be done anyways. So you have all that money to replace the cladding anyways. So now you're just adding insulation and air tightness. So when you're looking at retrofits, the most important thing is to think about what you're saving. So if you have a building that's got a good interior and a shitty exterior, obviously do the exterior first. You're going to do the retrofit from the outside. If you're doing a retrofit and you find you're going to do the outside because it needs new cladding and windows and a roof, and the inside's not what you want either, then you'll find you're demoing the outside and the inside because you're going to change your kitchen around, put new bathrooms in, change the floor plan around. Oftentimes in that case, you're better off taking it to the foundation. So if it's got a slab, take it to the slab and build up from that slab, right? You can reuse the slab. That's pretty straightforward. Even add on additional slabs, not that hard. And if it's in a colder climate like down south, you might put an insulation skirt or perimeter insulation around that slab as part of the retrofit. And then because you're building up with all new framing, the walls are straight. Things can kind of proceed like in a new building with very predictable costs. So that's pretty much what it comes down to. What determines whether you can do it from the inside or the outside is what you're going to save. If you're going to keep the outside because it's in good nick, then demo the inside and you can do it from the inside. But I think personally, if I have a choice, if they were both equally good, I would choose to retrofit from the outside. Oftentimes in retrofits, you'll see people doing solutions for, let's say, direct fix cladding that would not be allowed in a new building in New Zealand. So that doesn't mean that wall is going to fail. It just means it has a higher chance of failing. It's more sensitive to workmanship, right? And why would you want to basically make a building brand new when you retrofit it properly with a construction that wouldn't be permitted today?
To dive into that a bit deeper, Jason, if we're going from the outside, how can you explain exactly what is the process of retrofitting those walls from the outside?
It depends completely on what kind of walls they are, but let's assume that they are timber-clad villa. So there's a number of approaches to do it from the outside. I think you probably have done a podcast with the Parker wrap on it, which is effectively you put a fully adhered weather tightness membrane directly over the existing weatherboards, don't even take them off, and you put an exterior insulation, battens and cladding on a ventilated cladding. So you've got a brand new ventilated clad wall, just like you do today for a brand new building, with continuous exterior insulation. And then you can put new windows in with some quite clever installation approaches. The other approach for that same wall would be if the cladding was, let's say, was rotten, which I've had buildings in that case. So you could pull all that cladding off, tidy up the framing. If there's any framing that needs to be treated or fix the plumbing and wiring, insulate, put a rigid air barrier on that acts as an air control layer, put some external insulation, and then put your cladding on. You could have a brick building where you pull the brick off and do that from the outside. If you're doing a brick building and you want to keep the brick, you generally need to do it from the inside, of course, and that's another story. If you've got a tilt slab building or a masonry building, there's several other insulation systems you can use on the outside that work really well, ranging from external fiber insulation with battens and ventilated cladding to putting on polystyrene blocks and directly plastering it, like we did with PI House, which you've seen the case study for that. Actually, I think you worked on that project, didn't you?
Yeah, I was very closely involved with Terry on that project, yeah. It'll be interesting to hear more about the approach that you took there, because that was an interesting one. Obviously, there was a reasonably expensive renovation, wasn't it?
Yeah, that was a renovation that did both the inside and the outside to great extents. I'm not sure in the end if it wouldn't have been wiser to take it down to the slab.
So if you've done the walls, what are you going to do in the ceiling then?
So again, let's think about that same villa, which is probably the most common setup. That would typically have a rafter roof with, steel roofing, and then would have gypsum board down at some layer somewhere, perhaps, with insulation thrown on top in the ceiling. So it depends on exactly what your goals are. In general, my approach is to get the building as good as possible because you're replacing things anyways. So in my case, I tend to want to pull the insulation up to the rafter plane and introduce air tightness and insulation up at the rafter level, turning the truss bays into basically a giant service cavity for ductwork or whatever, right? And at the same time I did the roof, I would put in the ventilation system because it's going to be in that ceiling cavity. And with the roofing off, it's quite easy to get stuff in the roof. That's really hard to do otherwise without destroying the inside of the building. And if it's a skillion roof, it's done relatively the same, right? You've got insulation up in the rafter plane.
So you've got your walls, your roof, you've got your ventilation, you've got your windows, and then of course you do need to think about shading, don't you?
Yeah. One of the reasons that we tend to do a performance snapshot on every project, even ones where it seems quite clear what the solution is going to be, is because it's amazing how much you learn about what glass matters. I remember we did a retrofit. We looked at a retrofit job here in Wellington maybe about a decade ago now. And I looked at the building, thought I knew the solution, ran the model, and realized, because in the model we modeled the site accurately, that it didn't get sun for 3 months in the winter. I mean, any sun at all. The sun didn't hit the building in the winter. So, it needed Queenstown style insulation here in Wellington, even though it was fairly close to the ocean, so it never gets below zero, right? But it needed to be built as if it was in Queenstown because it was in Queenstown in the winter. And that building was horribly cold in the winter and wet. And because they was done properly,
So another project that you've talked about in your book is Till Schlimm's project up north. Can you tell us how that one was done?
Yeah, Tillo's house. So that's up north of Auckland, actually. So that project was I want to say it was 1990s, but it may have been late 80s, timber frame building, built above code at the time. And Till wanted to have a passive house, effectively. So that project was actually certified as a passive house in the end, not as an EnerFit project, because they met the passive house air tightness target of 0.6. So even though it's a retrofit, it's met the full passive house standard. So that project had perimeter insulation added to the existing slab, or insulation skirt is what they would say in Canada. And then external wood fiber insulation put over the outside of the existing timber studs, and the insulation in the studs tidied up. So that wood fiber insulation went over a membrane as the air control layer on the outside of the studs, and then battens and then cladding went back on. And then the roof was done fairly similarly because because the inside of the building was quite nice and we didn't want to change the inside of the building very much. The main part of the building was not touched effectively on the inside, other than adding openings for ventilation and a bit of threading the ventilation ducts through the building, of course, which is always difficult. So that ceiling, we left the existing timber cladding on the underside of the ceiling, which was visually very beautiful, and then left the insulation between the rafters and then put an air control layer and wood fiber on top. Because that climate is quite warm and humid up north of Auckland, that was modeled for moisture performance to make sure that we wouldn't have any moisture issues in that ceiling assembly. And what makes it work is the wood fiber insulation is very vapor open, so it dries out quite quickly. And then steel roofing went on top. And then all the windows were replaced with double glazed windows imported from Tillo's hometown in Germany, I think. And mechanical ventilation with heat recovery put in, a heat pump water heater, and that was a full-on deep energy retrofit.
Sounds like a fantastic outcome there.
Yeah, it's super comfortable.
Alongside your book, you were telling me that you've been running, or you will be running, a course, am I right, to actually expand on this?
Yeah, so we ran the very first retrofit expert course here in New Zealand and Australia. It's intended to be an add-on course for Passivhaus tradespersons and Passivhaus designers or consultants. So it takes and teaches them all they need to know about EnerFit, the whole process, how to calculate those numbers, look through constructions. Because we've had so many moisture problems with both new buildings as well as some retrofits with unintended consequences, we took that time to actually use some of the material from the book to make sure the builders especially got into those constructions and learned when they're going to put themselves in trouble. So that is quite challenging because it's teaching moisture and heat transfer to builders, right? So I want, not that builders aren't more capable than I am in a lot of things. They obviously are, or else I wouldn't hire somebody builder to build my house. I'd build it myself, right? But they're business experts and quantity surveyors and builders, right? They've got all these skills kind of packaged up, but it doesn't tend to involve computer modeling of building assemblies. So what that course did was to make sure that they had the practical knowledge to know what constructions they can just go ahead and use and what constructions tend to cause additional problems. So a good example is we've had several building failures in Wellington recently where a really good roofer has done the job. So the roofer's put on a really, really good roof. Like the roof doesn't have any leaks in it. But the problem is the roof doesn't have any leaks in it. So there's no air leakage either. So that building, although the roofer didn't realize it, depended upon a lot of air leakage through that roof assembly into the roof space above the insulation, because the particular building I'm thinking of had quite a bit of air leakage from inside the building into the ceiling cavity. And the insulation in that ceiling was put in pretty well. So it actually works. So because the insulation in the roof is working quite well, the roof gets fairly cold. And because of the air leakage, they get condensation problems. Whereas before, when they had their old roof, there was quite a bit of air infiltration and it managed the moisture well enough. So the problem with retrofits is you can introduce problems that you didn't have before by making things better. And that's not what you want, right? It's a roofer doing the best job you can possibly imagine. Like he did just what you want him to do. No driving rain's going to get in. But unfortunately, it caused the client to have some brown ceilings.
It sounds like people definitely need to be thinking carefully before they go ahead with this. Where do you recommend they start with a project like this? Who do they speak to?
Well, I think that probably the best thing to do is to get a performance snapshot done first so they can understand what the hell they're doing and decide on whether or not they're going to manage themselves and use a local draftsperson or if they're going to get an architect or designer involved. If you end up going further down the deep energy retrofit path beyond the point of doing simple things like just windows, replacement components kind of things, then you sometimes do need to get an architect or designer involved and often a builder. So, for example, one retrofit project we just talked about a few weeks ago as a team, went in and talked to the client, looked at the house, agreed we'd run a performance snapshot, and then said, well, let's hold up. You're going to need, like, looking at doing a lot more work than just revitalizing the components. You should get a builder in and get a designer in to get this done properly because you're going to have to get it through council as well. So at that point, we stopped and brought in a builder or an architect to work with them on that. So the first thing is deciding what you want. Second thing is modeling it to understand what you need to do to get there.
Thank you very much. And we will definitely put a couple of links in the description below this podcast so people can actually start reading up on it. When is your book going to be available?
We've just got the final draft back from the editor. So it's on my desk. And I'd like to say it'll be done in about 2 months.
Well, that's
But the reality
good.
is, in about a month, it'll go to Green Building Council to go to the graphics layout folks, because New Zealand Green Building Council and EECA are both supporting this. So they've partially funded the book. And Green Building Council has been gracious enough to agree to get the graphic design work done, which is something they're really good at. So it'll be a much, much better book because they're involved as well as EECA. So that means it may be several months yet.
Fantastic, Jason. Thank you very much once again. And yeah, look forward to chatting again soon.
Thank you. Cheers.
Sharing knowledge is at the heart of our strategy to make buildings better for everyone. Sign up for our podcasts to learn more about creating healthy living conditions by protecting building structures from external and internal moisture damage. Thanks for listening. Looking forward to having you with us next time.